In this video, number 13, we will run the design using FrameCE. So before we do that, we will just check the load combinations. Okay, I will go to load tab and we have here create load. So this is our load cases 1, 2, 3, 4, 5. So the wind, I just deleted the wind. So okay. So in this the wind definition, or how to define the wind, is already uploaded, and in this case I deleted it. So I can also define it again, but for now I will just consider this load cases gravity and earthquake. So so this model doesn't have a wind, but we can define it again. So in this case I will just show how to review the wind load. So we already upload the load, how to do the wind load case and the load combination. So for now, let's say I have this load combo. So if I want to add, so I will just click this one and primary. So I will just click exit. Okay, that is the how to define the load combination. So we have that video earlier. So in this case, we will just consider this gravity load combo. U grab 1 and U grab 2 and U4, U8, U12, U16. So we have here the load combinations in this Excel. So I will just click this exit. So we have this Excel and we can input all of these load combinations. Okay. So for now, I will just consider these load combinations. So I will just consider these load combinations for the ultimate limit state or for the ultimate design. Okay, click exit. So before we proceed, I will just show this added code provisions in classification of structure. This is in program and design criteria. I updated it, and we have here the classification of structure of our structure, or the occupancy is in this standard occupancy case. So the seismic importance factor or the wind in seismic factor is 1.0. Okay, then I already add the clause from the NSCP. This is located in this 104.3.4. This is foundation investigation. So I will just please read this one, and this is the requirements for 2-story or higher. So you need a foundation investigation, and also in the footprint requirements, this is the number of boreholes, and also the depth is also written here. Okay, so we'll go to design. So I will just click this run analysis. So the design we want to do for now is individual design. So we will go to design and I will just run this linear elastic. So meaning I will just click the element. So okay, after running the linear elastic, the FrameCE will ask us to select what is the load combinations to use. So in this case, I will just, let's say I will just check the structure for gravity load combinations only for now, because I want to before proceeding to the load combinations with lateral, with earthquake and wind, I want to know that the that the structure or the element or the structural elements are found adequate in gravity load combinations. So that is my procedure. So I will just check it for the gravity first. Then after running for the gravity, and let's say I found out that all of the elements are adequate in gravity, I will proceed to the checking with the load combinations including wind and earthquake. So that is my procedure. Or if you want to have your own procedure, you can do that. You can check all of the load combinations. So for now, I will just investigate if my structure is adequate in gravity load combination. So I will just click OK. So in this individual design, you have to check, or you have to click that one and click this individual design. You want to design that column. So then it will ask you what rebar to use and the design beam moment. So face of column or center of the joint. So I will select face of column because we have the rigidity of the joint. So that let's say this is your column. So this is rigid zone. So that's why the moment I want to consider is at the face of the column. Okay. So I will just click OK. So I will just use 20 mm in this column. Click OK. Then the FrameCE will start to check that capacity of column. So I select 3 column, and this column adequacy check is considering 3 columns that I select. So let's say okay. So this is the properties 400. So this is 4. So this is 3.2. Okay. So this is your biaxial bending. This is the demand of the forces, and this is the capacity of the section. Okay. So for this gravity load combinations, we have this 320 mm at the face. So this is 8 pieces of 20 mm. So this is found adequate. Okay, this is for the gravity only. So I will just say accept. Okay, so meaning my corner columns are adequate. So I will just check the center column, and I will just click individual. So because this column is having different or having large tributary area, so in this case the column is adequate. Okay, but in this case the ductility requirements is not yet checked, because that is the requirement for SMRF. So this is stress based. Okay, so this is our column interaction diagram. I will just click accept. So now I will run the, let's say we will select this beam, and let's say individual check. That is for gravity. Okay, so our beam is safe. So also take note, this stirrups is based on gravity. So this is not yet SMRF. So we have another checking of SMRF. The spacing here is d over 4, and the spacing here is found to be d over 2, and also here is d over 4. So we have a separate checking of that. So most of the software check the beam and column for the stress base. So for the SMRF requirements or seismic detailing, we have to do it by our own. But also the FrameCE has its own, I just click accept, has its own checking of SMRF. So this is the SMRF of the FrameCE. So we'll go there after we run the design plus plan. So I will just go back, and before we do the design plus plan, we can also, I will just let's say for this beam, I will just explain this one. In FrameCE, we have here, let's say at the roof, so we have, supposedly we have this beam to be one element. So but in FrameCE, because we have here another beam connected, so it become 1 and 2 elements. So in our case, this should be, let's say this is element A, so this should be 1 element. So in FrameCE, if you have to click the design, this one, if we select this one and we will design that, so I will just click the run elastic analysis. So let's say we are dealing with a gravity load combo. So select this one, then individual design. So this half of that element, or that element is, let's say this is the element and there is a joint here. So in this case, the element that can be designed is this one. Let's say we have this joint here, or we have the support here, support. So in this case, because we have 8 meter beam, so as you notice, this is 4 meter. So what to do is, this is your beam at left, the rebar here in the section, and your mid-span beam in this case is this one. Okay, so that is the one thing that to observe in FrameCE. Okay, because in this checking for the 4 meter, the midspan is located here, not here. So this is the midspan. This is the design in this case. So okay, I hope this is clear, because when there is a joint, the FrameCE is automatically separating that element. I will just click accept. So that is the individual design of the FrameCE. Okay, I will just make another video how to use this SMRF checking. Then this is for video number, let's say 14, and this is for video number 15, the design plus plan. Okay, 14 or SMR. Okay, so I will just end this video.